Okay, let's talk about something super exciting happening in the world of batteries: solid electrolytes. You know how most lithium-ion batteries, like the ones in your phone, or maybe even your electric car, use a liquid inside? That liquid is the electrolyte, and it helps move the energy around. But researchers are pushing towards using a solid material instead. This leads to what we call solid-state batteries, or SSBs. Why the big push? Well, the biggest reason is safety. Those liquid electrolytes in current batteries can be flammable. If the battery overheats or gets damaged, things can go wrong, sometimes leading to fires or thermal runaway. Solid electrolytes are inherently non-flammable and don't leak. That's a huge safety upgrade. Plus, their solid structure can physically block the growth of pesky lithium dendrites, tiny spikes that can cause short circuits in regular batteries. They're also more stable thermodynamically, meaning fewer unwanted chemical reactions and slower temperature increases if something does go amiss. But safety isn't the only perk. Solid electrolytes promise some serious performance boosts. A major goal is higher energy density. By enabling the use of high-energy materials like pure lithium metal for the anode, instead of the usual graphite, SSBs could potentially store much more energy in the same space. Imagine EVs with significantly longer ranges or gadgets that last longer on a single charge without getting bulkier. Some researchers are aiming to double the energy density we see today. They could also lead to longer-lasting batteries. Solid materials tend to be more stable and degrade less over many charge and discharge cycles compared to liquids, especially under heat stress. They might also perform better across a wider temperature range. Think extreme cold or heat where current batteries struggle. And what about charging? While there are challenges with moving ions across solid surfaces, the potential for much faster charging is a key target. We're seeing prototypes aiming for charge times like 15% to 90% in under 20 minutes. Now, not all solid electrolytes are the same. There are a few main types being explored. Oxides, which are ceramic materials, are very stable, but can be brittle and sometimes struggle with ion movement at room temperature. Sulfides generally move ions much faster, even faster than liquids sometimes, and are more flexible. However, they can be sensitive to moisture and air. Then there are solid polymers, flexible, lightweight, and potentially easier to manufacture, but they often need higher temperatures to work well and aren't as strong. A really promising area is creating composites, mixing these materials to get the best of both worlds. Maybe the high conductivity of ceramics with the flexibility of polymers. Of course, there are hurdles. Getting ions to move quickly at room temperature is a challenge, especially for oxides and polymers. Making sure the solid electrolyte makes good, stable contact with the solid electrodes is critical. That interface is key. And figuring out how to manufacture these things cheaply and at scale is a major barrier. Producing large, perfect layers of these solid materials isn't simple. Plus, completely stopping dendrite growth, especially with lithium metal anodes, still needs work. But innovation is happening fast. Researchers are developing new materials, designing clever interfaces, and using advanced manufacturing techniques, even AI, to tackle these problems. Companies are building pilot lines. We're moving from just the chemistry to thinking about how these cells fit into a whole battery pack, considering mechanical stress and heat management. So, what's the bottom line? Solid electrolytes are a really big deal for the future of batteries. While mass production and proving long-term reliability are still challenges, the potential benefits, safer, longer-lasting, higher-energy batteries, are huge. Major companies are investing heavily, and we might start seeing the first commercial applications, especially in EVs, in the second half of this decade. It's a space to watch closely as we power towards a more electric future.